Hi everyone, welcome to CSC classes. In this particular video, I will discuss about what is Kubernetes. So Kubernetes is nothing but it's open source container orchestration platform that automates many of the manual processes such as deploying, managing, and scaling of the containerized application. So Kubernetes is an ideal platform for hosting the cloud native application that requires the rapid scaling and like real-time data streaming. So originally it was developed by Google. So it gives you the platform to schedule and run the containers on the clusters of the physical and virtual machines. So let us try to understand further. So what are the benefits of the Kubernetes? So it orchestrates container across multiple hosts. So scale the containerized application and their resources, makes the use of hardware to maximize the resources, and it provides the monitoring and health checkup of the nodes and self-heal your apps with auto replacement, auto restart, auto replacement, and auto scaling. So automates the rollback and offers the security. In case of any errors, it automates the rollback and offers the security. It mounts and adds the storage to run the different applications. So what are the components of the Kubernetes? So we have clusters and compute nodes, and clusters are the building blocks of the Kubernetes architectures. So the clusters are made up of the nodes, each of which represents a single compute node. So each cluster is made up of a master node that serves as a control plane for the clusters and the multiple worker nodes that deploy, run, and manage the containerized applications. So this is the architecture of the Kubernetes. We have a master node and we have a worker nodes. So master node is one of the most important components of Kubernetes architecture, and it is an entry point for all the tests. So we have the different components of the masters are we have etcd, controller manager, and scheduler, and REST API server. The etcd. So the component stores the configuration details and essential values. So it communicates with the other components and perform an action. It manages the network rules and post forwarding activities. So what is a controller manager? So server that runs in a continuous loop is responsible for gathering the information and sending it to the API server. Works to get the shared set of clusters and change them according to the destination state. The key controllers are a replication controller, endpoint controller, namespace controller, and service controller. So controller manager runs the controller to administer the nodes and the endpoint. So third one is the scheduler. It assigns the task to the worker node. So it is responsible for distributing the workload and store the resource usage information. So tracks how the working load is used on the clusters and places the workload on the existing resources. The fourth component is API server. Uses the API server to perform all operations on the cluster. So it controls the entity like that receives all the REST requests for modification, serving as the front end to the clusters. So implements an interface which enables the different tools and libraries to communicate. So we have a kubectl which manages the cluster, and we have a worker nodes. So what are the components of worker node? We have a pods. We can see that under the pods there are different containers are there. In the containers the applications are running. So we have a Docker, and we have a kubelet and kube process. So let us try to understand one by one. So what is a pod? So pod is one or more containers controlled as a single application. So it is also encapsulated applications, containers, storage resources is tagged by unique network ID and other configurations. So we have a Docker. So it helps to run the application in isolated, lightweight operating environment. It runs the configuration pod. So responsible for pulling down and running the containers from the Docker images. So we have a kubelet. So service responsible for conveying the information to and from the control panel. Of the pod from the API ensures that the containers are working efficiently. So responsible for maintaining the work status and the node server. Kube proxies acts as a load balancer and network proxies to perform the services on the single node. So manages the pods on the nodes, volumes, and secret manager, and the creation of a new containers, health checkups, proxy service that runs on every node that makes the service available to the external host. So what are the different components of the Kubernetes? We have a nodes. A node is the smallest unit of the hardware in Kubernetes. It may represent a single machine in the cluster, or it may be a physical machine in the data or the virtual machine. So what is a cluster? So cluster represents a group of nodes to form a powerful machine known as the cluster. When the node is added or removed, the cluster shifts. So we have a container. So what are these containers? They are self-contained environment to execute the programs. The programs are bundled up to the single file and shared over the network. Multiple programs are added to the single container with the limit of one processes per container. So we have a pods represents a group of one or more application containers bundled up together and is scalable. If the pod fails, the Kubernetes automatically deploys the new replicas to the pod to the clusters. We have a deployment. So pods are managed with one or more layer of abstraction known as deployment. So deployment is a fundamental purpose is to indicate how many nodes, how many pods are running simultaneously. So ingress is allows us to access the Kubernetes services from outside clusters. You can add an ingress to the cluster, either an ingress controller or load balancer. So it provides a load balancing, SSL termination, and name-based virtual hosting. So we have pods and deployments. So already we have understood pods are a group of containers that share the same compute resources and same network. The deployment controls the creation and the state of the containerized application and keeps it running. So it specifies how many replicas of the pods should run on the cluster. If the pod fails, the deployment will create a new. So if you don't want to manage the Kubernetes, you can go to Amazon Kubernetes Services. It provides a managed Kubernetes control plane, highly available clusters, automated the version upgrades. We'll try to understand the further video. We'll try to understand the demo. In this particular video, I will discuss how to create the Kubernetes cluster in AWS. So what are the different steps that are involved? The first step is creating the IAM role. The second step is creating the cluster. Third step is installing the AWS CLI. The fourth step is creating the access keys. The fifth step is installing the kubectl. Sixth is like checking the cluster status. Seventh is like creating the worker node. And eighth is check whether the worker nodes are ready and create the pods, create the service and access the applications. So we have AWS console over here. So what I'm going to do is I'm trying to create the roles, IAM role. So here I will go to the IAM here. So already I have created the roles. If you are not created, so we need to create the roles here. So role. So what are the policies that I'm going to attach? Let us try to see that. So here I will say master node. So these are the policies that I have attached here. My EKS cluster policy. So this is a policy for the master node, and for the worker node, what is the roles? What are the permissions that we need to attach here? My role for worker node. So these are the permissions that we need to attach. EC2 register, container registry, read only, Amazon EKS CNI policy, Amazon EKS work node policy. So these are the permission policies that I'm going to attach here. So after this, I'm going to go for the next step here. So what is the next step that is there? Creating the cluster. So in EKS, so we need to create the cluster. Before that, I tried to install the AWS CLI. So how to install the AWS CLI? So you need to go to the particular window here. So update the latest version of the CLI. So here we have to install in Windows. If you have Mac OS, Linux, we can install over here. So I'll copy this. So I'll paste it in the CMD, and you can create the so you can install the Amazon CLI. So already I have installed. So just I need to check whether it is successfully installed or not. So it is successfully installed. So after installing AWS CLI, so we need to configure this AWS configure. So for this we need access keys here. So what is the access key? So these are the access keys. How to create the access keys? If you don't have an access key, so we can go for this security credential and you can create the access keys. So already I have configured that. So if you don't have, so this is the access keys that I have created. So if you don't have, you can go and create the access keys. So after creating the access keys, the next step is like I want to create the cluster here. So how to create the cluster? So I will say yes, Amazon Kubernetes services. So I'll open this. So add the cluster. So create this. So type the name of the cluster here. So I will say my cluster. So this is the role, my role for master node. So I will say next. So VPC, so default VPC I'm going to use. Subnet, I'm not going to select this because it is causing some problem. So choose the security group. I'm not going to choose any security group here. The remaining things I'll keep it as default. So the cluster is getting created now. It will take some time. Say create. So it is taking some time here. So the status is, it is showing it as creating. Let us wait for some time. So I can check the status of the cluster, whether it is created or not. So by using this particular command. So I'll copy this and paste it in the CMD over here. So it is active now, it is created. So I can update the cluster information by using this particular command. So updated the context. So after this, I'm going to install the kubectl command here. So how to install the kubectl command? So here it has been given. So I'll just copy this Windows I want to install. So copy and paste it in the CMD. So already have installed here. So if you have successfully installed, so you will get this particular details. So after installing, so now I'm going to again I am enrolled. So check the cluster status and update the cluster information we have done successfully. I will create the worker node. So how to create the worker nodes? Again the same thing. We'll go to the EKS and in the cluster I'm going to open this particular cluster and under the compute tab, so add the node group. So we're going to add the node group. So I will say my node group. So my role for the worker node. So here I am going to remain at the role as it is. I'll keep the role as it is. So I'll say next. So you select the instance. So here the instance is t2.micro. So I will say t2.micro. T2.micro. The disk size I am going to choose as 4 GB. The node size, how many worker nodes you want? So I need 2 worker nodes. So I'll keep it as it is. So the subnets, subnets I'll keep it as it is. Whatever I chosen for the master node, I will keep it as it is. So remaining things I'll keep it as defaults. So I will say create. So it is going to create. It will take some time. Let us wait for that. So we can check over here. So how to see whether the nodes are active or not. So kubectl get nodes. So this is how we can get the nodes. So these are the IP addresses. So the status is ready. So these are ready now. So the next step is like creating the pods. So how to create the pods here? So have the particular file here. So using this particular file, I'm going to create the pods here. So I will go and open this file here. So here in this. So this is the particular file that I am going to use. So it will be using deployment object. So this deployment object will create the 2 pods. So here it is given it as a 2 pods. So this is the app, example app. So it is running under the port 80. So this is the Docker image that I am going to pull whenever particular pods are deployed. So this particular image is going to be running. So I am going to create this particular pods using this file. So how to create the pods here? So I will use create -f. So here I should use kubectl. So this is the command that is used to interact with the cluster here. So -f. So app.pym. So this is how we are going to create the deployment object, and using this deployment object we'll create the pods. To see whether the pods are created or not, so make use of kubectl get pods. So this is the name of the pod. So here it is showing the status as it is container is creating. So first it will create the containers, then the status will be changed to the running state. So this is the age of the pods here. So how to see the status changed here? So run this command again. So one of the pod is running, one more is like still it is creating. So let us. So both the pods are running. So after this, what I will do is I am trying to create a service. So the service object is created such that we can access the application outside the AWS. So how to do that? So I have the particular file service.yml. So go and open this particular file here. So go and open this. So here it is service.yml. So I will just type the name of the file, services.yml, and I'll open this particular file. So this is how we will try to run this application on the load balancer and try to access it outside the particular browser. So we'll try to access it using the browser. So how to do this? So again, I make use of kubectl create -f. So what is the name of the file here? So it is services.yml. So the service is getting created here. So I will say how to see this kubectl get service. So I'll get the services. So these are the service that is running. So I'll copy this XML IP and see whether I can access it outside. So go and mark this. Right. Edit, copy, go to the browser, paste it. So wait for some time. So I'm successfully able to run this particular application. So in this way I can create the pods here, and I can create the containers outside that, and I can run the application. So this is all about the Kubernetes. And if you like this video, subscribe to the channel. Thanks for watching.